Alright guys, in this problem we're going to be solving for three different things. We're going to be solving for weight in newtons, height, which is going to be measured in meters, and then at the very last part of this we're going to calculate the speed at the bottom of the hill. So, let's go through this problem. You're on inline skates at the top of a small hill. Your potential energy is equal to 1,000 joules. The last time you checked, your mass was 10 kilograms. I'm sorry, not 10, 60 kilograms. So the first step, guys, is to note the formula with which we need to solve in A. So it says, what is your weight in newtons? The formula for weight is equal to mass times a gravitational constant. This gravitational constant on Earth is 9.8 meters per second squared. That number will vary depending on what planet you're on, but as long as we're talking about problems here, and it's assumed that there's no other planet mentioned, you're just going to assume that it's on Earth. And so the gravitational acceleration on Earth always is 9.8 meters per second squared. So now that we know the gravitational constant, it's a very easy problem. We're going to plug in our mass. Weight is equal to a mass of 60 kilograms times 9.8 meters per second squared. And when you multiply those numbers together, you get a weight that's equal to 588 newtons. Now, I want you guys to note that 1 newton is equal to 1 kilogram times meters divided by seconds squared. That's the unit that we're solving for. In the problem that we worked, we could not cancel any of the units because nothing was alike. So 1 newton is equal to 1 kilogram times meters divided by seconds squared. Now let's move on to question B. It asks, what is the height at the top of the hill? So it says that we're on inline skates at the top of the small hill, and our potential energy is 1,000 joules. So in order to solve for height, we need to find a formula, or think of a formula, that involves height, and then would provide us with potential energy and with mass, or weight in this case, since we've already solved for it. So thinking about this, potential energy's formula, PE, is equal to mass times gravity times height. Since this part looks pretty familiar to you guys, which is what we just solved for when we were solving for weight, we can also write this as potential energy is equal to weight times height. So, since we already have the weight, this problem would make a lot more sense for us to use. So, we're going to plug in everything that we know, and we know that our potential energy is 1,000 joules, and we know that it's equal to our weight, which we just solved for, is 588 newtons, times an unknown height. Now, it's a very simple algebra problem from here. We're going to divide both sides by 588, divide by 588, and when you divide these out, you guys are going to get 1.7 meters is equal to our height. Now, you may be asking, how did we end in the unit meter? Well, we need to look at what 1 joule is equal to. 1 joule is equal to 1 kilogram times meters squared divided by seconds squared. And if you recall, 1 newton was equal to 1 kilogram times meters divided by seconds squared. So when we divided the joules by the newtons, we were basically dividing 1 kilogram times meters squared divided by seconds squared divided by 1 kilogram times meters divided by seconds squared. So it looked something like this. 1 kilogram times meters divided by seconds squared. Now, you're able to see that we have some like units that we can just get rid of. So we had kilograms, those are the same unit. We have seconds squared, and we have seconds squared. And then we have meters and a meter. But in this case, we're left with a single meter. So it was, our final unit was indeed in meters. So 1.7 meters was equal to the height. Now, going back up, let's look at C. The C's got a little bit of a trick to it. If you start rolling down this hill, your potential energy will be converted to kinetic energy. At the bottom of the hill, your kinetic energy will be equal to your potential energy at the top. So calculate your speed at the bottom of the hill. So what this is telling us is that this 1,000 joules of potential energy that we start with is going to be the same as what we finish with at the bottom of the hill when all of our potential energy has been transformed into kinetic energy. And we know that that number is the same due to the law of conservation of energy. It says that energy cannot be created or destroyed. It can only be changed in form. So our new equation is going to involve some type of kinetic energy. And there is an equation to explain this. We have 1/2 kinetic energy, is equal to 1/2 mass times velocity squared. And in our problem, we already know our mass. Our mass is 60 kilograms. Do not get that confused with newtons. Newtons is strictly weight, okay? Kilograms is the unit of mass. So our kinetic energy is 1,000 joules. And it's equal to 1/2 60 kilograms times velocity squared. Now, since we're solving for v squared, we need to combine everything on the right side of this equation that we can. Luckily, there's two like terms here. We have 1/2, and then times 60. So 1,000 joules is equal to 1/2 of 60, which is 30 kilograms times velocity squared. Now, from this step, we're going to divide both sides by 30 kilograms. So we can cancel those units, that's like terms. Divide this side by 30 kilograms. And when you divide 1,000 by 30, you're going to get 33.3 meters squared divided by seconds squared. And that's because, remember that a joule is equal to 1 kilogram times meters squared divided by seconds squared. So when we divided these numbers, we canceled out the kilograms because they were like terms, and we were left with meters squared divided by seconds squared, which looks like the unit that we need when we're solving for velocity. Velocity's units are meters per second. So let's see what happens now. These both have squares, and we can't end with a square, so velocity squared. Now, as you guys know, we can't end when a variable is squared. So we need to take the square root of that variable in order to solve for both sides. So we're going to take the square root of v squared, and we're going to take the square root of 33.3 meters squared divided by seconds squared. And when we take the square root of all of that, we're going to get 5.77, and then meters per second is equal to velocity. And this is our final answer, and that's the answer that we wanted to end in. I hope this video helps. If you guys have questions with any of those units, I know that can be very tricky. I'll be more than happy to help you guys in any way that I can. Just let me know.